All right, good morning. So this is our second last lesson. We jumped from 7.1 all the way to 7.6, and then tomorrow or next day or next lesson will be 7.4, which is substitution. So 7.1, what did we go through? We kind of went through how to represent systems of equations in word problems. Okay? A certain example was one person has one more apple than the other person, and they have a total of 300 apples. How many apples do they have? And then you could make two equations for that type of question. Okay, so that's what we did in 7.1. Now we're not worrying about the word problem part. Assume that you got a word problem and you created these two equations here. We're going to be dealing with what happens after you've created your equations. What do you do with them? Okay, so in this question it's saying two numbers add to -2. Those two numbers, the first one when multiplied by -2 and subtracted from 2 times the other number should equal 4. So again, that doesn't really make much sense, but in word problems sometimes you come up with just different equations and you have to know how to use them. So we know how to graph linear functions. Turns out these two formulas are linear functions. So the reason why is because you don't see any x squared variable, or you don't see any square root symbols over a variable, or you don't see like an x to the power 6 or anything like that. Or you don't see any like x, y's, nothing like that. You just see variables with no exponents. So that means they're linear. So what you do in these problems is you kind of want to graph both these lines. These are two different lines because they're two different equations. So let's go with the first one. We have 1 there and we have 2 there. If we go to the number 1, let's try to graph that. What's the graph of x plus y equals -2? When I see that, I have no clue what the graph is. Okay, so how do we get it into a form that we can graph? Well, we know two different lines that are kind of graphable. Y equals mx plus b, and y minus y1 equals m bracket x minus x1. So we have those two equations. If you remember, this one's called slope intercept, and this one's called point slope. Okay, and again, one thing to remember with this one, it's always the opposite point that you think. So if the point on your line is 3, 4, you would put in here -3, -4, right? So that's how that equation works. But we have those two equations. By far, this one is the best one to always want to use, y equals mx plus b. So let's try putting it in that form. So it's like this. How do we rearrange it so it's like that? Really, your ideal situation is just do algebra to try to get y by itself. Right now the x is with it, so you got to get y by itself on one side of the equation. So how do I get rid of that x? Well, the opposite of plus is minus. Let's subtract that x to both sides. So we'll get y on the left side is equal to -2 minus x. Okay, so I subtracted that x over to the other side, and I got this. So now it kind of looks like this form, except it's kind of switched, right? My x is to the right and my number's over there. But we know we can just switch numbers around if we want. So it's the same as -x minus 2. Okay. So what's our b value? Our b value is -2. What's our m value? It's a negative. There's not a number, so it means there's a 1 there. It's -1. Okay. So how do we graph that? I could write that down. My m value is -1. If you want it in a fraction, it's -1 over 1, which might help you out. And our b value is -2. Okay. So if I see my b value of -2, that's where I start always when I'm trying to graph this. So b value of -2, I go to -2 as my y-intercept, because that's what b means. And then we want to use the slope to find out what the line looks like after that. So we start on our y-intercept, and we're going to go down 1 and to the right 1. Remember, it's rise over run. So we're going to rise up -1, which means go down 1, when we run to the right once. Okay, so I'm going to run to the right once and go down 1, and I'm going to put another dot there. Okay, it would do that forever. It would go side, down 1, side, down 1. That's what the line would look like. So if I take a ruler, I have to be careful in drawing this, but it would go like that. So this equation here means that line there. And how do I know? I rearranged it so that it looked like y equals mx plus b, because that's really the best tool to know how to graph things. All right, so now we got to do the same thing with 2. So we have -2x minus 2y equals 4. So we got to solve for y. Okay, so I'm going to rewrite that just so it's over here. You got to get y by itself. So what am I going to do? I'm going to get rid of this -2x by adding 2x to the other side. So now we have 2y, -2y is equal to 2x plus 4, because we added 2x to both sides. If you wanted me to write it down, I'd go plus 2x plus 2x. All right. So now we have that. Y is almost by itself. We have to divide by -2 now, because y is multiplying -2. So we're going to divide by -2, but you got to do it to everything on the other side, like that. So those cancel out there, and now we have y is equal to, this is 2 over -2, which is the same as -1x, plus 4 over -2 is the same as -2. And now I have my y equals mx plus b, y equals mx plus b. Again, it's not a plus, but let's write down what our slope is. Our slope is going to be -1 over 1 again, and my b is going to be -2. So now we start on -2 again, so we're starting on the same point that we did for that line. And we have to draw this line, and it goes -1 over 1. So it goes down 1 over 1, and look, it's exactly the same as that line there. So that is very rarely the case where you'll get the exact same line, but essentially I'm going to do the same thing, put my dots in, take my ruler, and I'm going to draw the second line on the graph. And we know that it's exactly the same as the other one. So it doesn't really look like 2 lines, but it is. So essentially, what does this mean? It means when you have a systems equation, your solution is where the lines cross. Okay, because generally lines look like that, where they'll cross like that. But ours look like this, where they go over each other like that. So the number of solutions in this system is infinite solutions, because the lines are over top of one another. Right? Because which points work for both equations is what it's asking. And here, every point on these lines work as a solution for both equations. Okay? So an example is this point. The one that we started with is on both lines, so that's a solution. What's the point of this line? The point of that one is 0, -2. So if I plug in this x value and this y value in these two equations, they will equal both -2 and 4. And I could choose any other point. Here's another one. I could also choose 1, -3. And I could plug that into both these equations, 1, -3, 1, -3, and they would equal -2 and 4. Okay? But it just says how many solutions are there? There are infinite solutions. Okay? So that was kind of a weird example. Let's try this next one. So how do we graph and find the number of solutions of these two equations here? Okay. So here I have one equation, two equations. So I'm going to write my first one here is 4x plus 6y equals -12, and this one's -2x minus y equals, oh, I don't know why I'm writing the next one already. We have to solve for y on this one to get the y equals mx plus b form, because that's how we know to graph it. So let's solve for y. We're going to minus this 4x to both sides of the equation. That cancels it out over there, and we get 6y equals -4x minus 12. And now we have to divide by 6 to get rid of that 6, but you have to divide everything. So now we have a y is equal to -4 over 6x, and the -12 over the 6 is the same as -2. I could simplify this fraction again if I wanted. So actually, let's do that. Y equals, it's the same as 2 goes into both of those. -2 over 3x minus 2. So now that we have that, we can graph our equation because it's in the form of y equals mx plus b. There's my m, there's my b. So we're going to start at the y-intercept, -2. So I'm going to go 1, 2. I'm going to start at that dot there and go the slope. The slope is -2 over 3, which is rise over run. I'm going to rise -2 when I run 3 to the right. Okay, so I'm going to go down 2 over 3 and put another dot. Now that I have 2 dots, I can draw my line. I just have to be careful that they keep that slope. So my next point would be maybe down 2 over 3. I'd have another point there just to make it easier to draw. And that's what that line would look like. Okay? Really what we're trying to find is what point will this line and that line cross. So this line is that line. So now let's see what that second line looks like. So I'm going to go 2 here and rewrite that. -2x minus y equals -1 there. We have to solve for y equals mx plus b so we know what it looks like. So here I'm going to add the 2x to both sides. That crosses that out, and now we have -y equals 2x minus 1. And now we have to get rid of that negative sign. So I'm going to times everything by -1. So that turns to a plus, that turns to a negative, and that turns to a plus. So my overall equation is y equals -2x plus 1. So that looks like y equals mx plus b. We start at our b value, which is +1, and we put a dot. And then we look at our slope here, which is -2. We want it in a fraction, -2 over 1, and it's going to be rise -2 over a run of 1. So I have to go down 1, 2 when I run once. Go down 1, 2 when I run once. Go down 1, 2 when I run once. So I'm going to put my second line there. So again, this is line 1, this is line 2. And they look like that. Okay, so all the question was asking, how many number of solutions are there? There is going to, where is it going to cross? It's going to cross right there. And so we know it's only going to cross at one spot. So my answer is there's only one solution. So you can see generally, most of the time, there will only be one solution for two different lines. Okay? So those are those two questions. I had infinite solutions here because they were straight one over top of another. Here we have one solution because there's only one point where the lines will cross, because you can picture this will go forever that way, this will go forever that way, so it won't cross down there, and then this one will go forever that way, this one forever that way. They won't cross up there, just at that one spot. Okay, what is that solution? We don't know how to find that quite yet. Okay, but we know that there's going to be one solution for these two equations. So now we go to this last one here. Let's denote it as 1 and 2. So let's solve to see what this is, because we can't graph this without putting it into y equals mx plus b. So we have 3x plus y equals negative 1. We have to solve for y. This one's a bit of an easier one. We have to subtract 3x to both sides to get y by itself. So now we have y equals negative 3x minus 1. We got to make this the slope because it's mx plus b. So I'm going to put that over 1. And we know our b value is negative 1, so I'm going to start there. B value of negative 1, or my y-intercept. And then my slope is, I'm going to go rise over run, or down 3 when I run once. So 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. That's what my line will look like. So let's draw this line. This is line 1. So we just drew what that equation is. It's that line there. So let's try number 2 now. It's negative 6x, negative 2y equals 12. So to get y by itself, so let's add the 6x to both sides. And we get negative 2y is equal to 6x plus 12. And now we have to divide by negative 2, but we have to divide everything by negative 2. That cancels that out, and we get y equals 6 over negative 2 is the same as negative 3. And then 12 over negative 2 is the same as negative 6. So here my slope is negative 3 over 1. And then my b value is negative 6. Okay, so we always start on the b value. My b value is 1, 2, 3, 4, 5, 6. Then my slope is, I go down 3 when I go over 1. 1, 2, 3 over 1. So it'll look like that. I can't really go down anymore. I could go back 1 and then up 3. I could go back 1 and up 3. So that's my next line. Let's draw this one. This is line 2. So what do we notice with this line here? We notice that the slope of that and the slope of that are the same exact slope, which means they're parallel. That word parallel means here, it means that they won't cross or that they have the same slope. Parallel means they have the same slope, but since their b values are different, you can see that they'll be on different spots in the y-axis, and since they're going the same rate down, you can bet that they won't cross. Okay, they won't intersect one another because they have the same exact slope. Okay, so 1 and 2 have the same slopes because we found that our slope were exactly the same for these two lines here when we put it into our y equals mx plus b form. Okay, so here there is no solution. There is no two numbers so that if you put them in these equations, we'll make negative 1 and both will make 12 there as well in that equation. So there's no solution for those two equations. Okay, so there's no way you could look at the two equations and say there's infinite many solutions without doing the math and drawing it. Here, there's no way you could just go straight, just looking at these two equations and saying there's only going to be one solution. So you got to do the math to see, kind of, is it this case? So we can see that there's one line over top the other. Here there is two lines crossing one another, and here there are two lines that are not over top of each other, but are not going to cross either. Okay? So these happen to be the three different cases that can happen when you have two equations, or two linear equations. You can have it where there's an infinite solutions, there's only one solution, or there's no solutions. So generally this is the most popular case when there's only one solution, because it's very rare that they go over top of one another, and it's pretty rare that they'll be parallel. And then if we flip over the page, it says possible solutions for the linear system. They have the solutions here. So you have one line there and one line there. So they're saying it crosses once, so there's one solution to the system. One equation and one equation. Here they have one equation and one equation. We can see that they're parallel but different y-intercepts, or different b-values. So there's no solution to it. It's parallel lines. Here it says they're called coincident lines, where there's infinite many solutions. You can picture one line there, and then we drew the second line right over top. It only looks like one line, but it's really two. Those two lines, since they have the same slope, you can still call them parallel lines with the same b-values. So it's really the same line. All right. So those are the three different cases you can get. So here's one more last example. Given the equation negative 2x plus y equals 4, write another equation that will form a linear system with one solution, no solution, infinite solutions. Okay. So when I see this equation, generally in linear, if you see an equation like this, you say let's put it into y equals mx plus b, because that is the main form I know how to work with. Okay. So I have to rearrange this so that y is by itself. Let's add 2x to both sides. And we get y equals 2x plus 4. That was a pretty simple rearrangement. So we have y equals mx plus b. I'm going to put the m over 1. So there we go. So if we want exactly one solution, what I can do is I just need any line that's going to cross this line. And the only time it doesn't cross is if it's parallel. Okay? And so that means my slope has to be different. So let's write an equation so that my slope is different. So pick another slope line. The main thing is you can't pick 2 because that's parallel. So let's choose a different number. Let's say 3. So if my slope is 3x, then it's going to intersect this line because the slope is not parallel. Because the only time that it won't cross is if it's parallel. And then my b value can really be anything. That doesn't matter. So I'll write 5 just because I feel like I like it. All right, so that's exactly one solution, is these two lines here. The reason why? Because our slope is different. Next one, no solution. So I want to get this answer here. So that means I need a parallel line with R1 here. Okay, how do you make a parallel line? You just need the slope to be the same. So let's go y equals 2x. There you go, our slope is the same. Let's see, if we want no solution, we had to have different b values. Okay, so that means it's just this b value has to be different than 4. So what's the number different than 4? Negative 200. There you go. You can put any number you want, just as long as it's not 4. That would make no solution because it would be a parallel line, different b value. Last of all, infinite solutions, the only way you can get that is if it's the same line as this. So it has to be the same equation, pretty much. So we pretty much just have to write this again because the slope has to be the same and the b value has to be the same for infinite solutions. So I'm going to write 2x plus 4. And there you have it. So you have the 3 different versions there. So here's the homework. Try it out. Page 448, number 4 to 8, 10 to 12, 19A, 20A, 22, and 24. Thanks.